Hello and welcome everyone to today's session. Uh, in today's session, I will be focusing on the one basic function called manipulate in Wolfram language. And I will be sharing some tips and techniques on how to effectively and efficiently use this function in Wolfram language to develop and create astonishing range of interactive applications with just few lines of input. This function is designed to be used by anyone who is comfortable using basic commands like table or plot. If you understand how to do those, this function will be very easy for you to start using. And you will also be able to develop small applets or widgets without learning any complicated new concepts or having any prior understanding of user interface programming ideas. So normally the output you get by evaluating a manipulate command is an interactive object. And how I have designed today's session is I'm considering that you are familiar with the basics of using the Wolfram language, including how to use functions, various kinds of brackets and braces, and how to make simple plots. Some of today's example might be a little bit more advanced or use some advanced functions, but it is not necessary to understand exactly how these work in order to get the point of the example. So let's start. And using manipulate is very identical to as you have been using the table function. So for example, if you have used a table function, so this is how you write table like n, and then you give the range of the n like from 1 to 10. So this is normally how you will give a table command. So simply replace this word in this example from table to manipulate, and you will see you will get an interactive object. So what I have done is just simply replace the word table with the word manipulate, and you get an interactive applications that lets you explore values of n with this slider. So you see, when I move this slider, I get an interactive value where the value changing is displayed in real time. So in both table and manipulate form, you see you give a variable n and the minimum and the maximum. And so this is used as an iterator both in the table function as well as in the manipulate function as well. So for example, let's take another example. So if I say wait, and I say like plot of sine of x, and then x is from 0 to 2 pi, and then I give n from 1 to 20. So now you see the moment you change the slider, you can see the values corresponding to that as well. So there will be a plus sign over here, so you can move these values, change it from here, and you can see how the effects of that are looking on there. So let me yeah. So it is no more a static function, you move the slider and you see that. Then there is a VCR play button like plus, and if you click on that, you can see certain values, or you can play around, or a panel gets where you can play around with that. So one more thing which you can do is, you see, now you have to open this plus sign to get all these values. There are another thing which I can do if I want to see the value of the variable without having to open the subpanel. So you can add another option which is called appearance, and I can say this appearance is this goes inside this. So appearance goes to labeled. So now you can see, without opening the slider bar, I can get the values displayed on the right side of the plus sign. So as I move the slider, I get the values in front of that automatically displayed into that. So this is basically the first hint that manipulate goes far beyond the relative simplicity of table, both in its output and in the flexibility and range. So similarly, like in table, which allows you to give more than one variable range, the same thing can be done in the manipulate function. So maybe you can have another function where you can have more variables now. So instead of having only one variable n1, now I can have two variables n1 and n2. And when I execute that, you see I automatically gets a slider bar which has, I get a slider bar which has like two variables showing, and I can move them around and see the effect of n1 frequency, or having to see the effect of n2 frequency over here. So you can have as many variables as you like, including similar to you have been using in the table function as well. So here is let's take another example of having more variables into the passing into the variable functions. And you can open any of the subpanels to see the numerical values, and you are free to animate and change as way as you like. So by changing any variable, you can see the effect of that as well. So how I normally see this function manipulate is a way to interactively explore a large parameter space. So you can move around that space at will, exploring interesting directions as they appear, as you will see in my upcoming sessions, how you can add more features which will help you to explore more easier and more rewarding. So let's call this whole section as my first heading, which I mentioned over here, is manipulate as easy as using table. So you are already aware with the table function. Similarly, you will play around with the manipulate function, just changing by the function into that. So let's go and look into more features and more ways how you can interact with them. So let's take another topic of doing symbolic output, how you will get the symbolic outputs, and how to do the step sizes using manipulate function. If you have any question in the meantime, you can just type it in the comment section or the chat section, and I'll take a look at that as well. So the previous example which we saw was more like graphical, and normally I show that as a very common example of using manipulate and developing a interactive graph. But what I want to tell over here is that this function manipulate is capable of making any Wolfram language function interactive, not just graphics. You can pass any function to this, wrap that into manipulate, and it will give you the interactive output for that as well. As I have told you how you can convert from table to manipulate as well. So one more thing which I want you to know is that when you remember when I did the table function, so you will see that by default the step size in table is 1. So what happened? What is this corresponding basic step size in the function manipulate? And when you do this, you will see that this is more like a real value. So it's not a step integer like in table. The minimum step size was 1, 2, 3, whereas in the manipulate function, it is said to be real in nature. So the moment I do that, it takes the real values of that from 1 to 2 and take it forward. So what is the how to handle the step sizes in the manipulate function? Because certain times, for example, in a function like this, when you are expanding alpha plus beta whole square raised to power n, having a real value doesn't give you any answers or doesn't make it interesting, because you are getting non-integer parameter values over here. So it is very important in these specific examples that how to mention the step sizes. So similarly, you can have a step size mentioned over here like 1, and now when you see it increases with the step size of 1. This is also the same format where in table you want to have a step size of 2. You enter over here so it can give the step size of 2. Similarly, in manipulate, you need to give a step size, because here it's default 1, here it will take the real number. So to make this example interesting, I need to give tell Wolfram language that what should be the explicit step size of the expand function over here to make it more interesting. So if I give it a step size of 1, now you will see that at one time a specific 1 value is displayed. And this will now allow you to create examples that go far beyond what you would be practical in the table command. And the important property of manipulate output is that there is no fixed panel size. So you see, as the size of the answer output increase, the panel size is automatically adjusted. So there is no fixed panel size or arbitrary limit as to how large the output panel can grow. It will depend upon how the answer is. So for example, if I make it 200, and then you see the panel size will decide automatically depending upon how my output is. And you see how fast the calculations been happening. The moment I move the slider, it is updated and it gives me the result for that. So similarly, as in the table function, if you want to use rational numbers like 11 divided by 24 or 71 divided by 144, so you can give the minimum and the step. Similarly, you can use the same function under the manipulate function as well. So if I use this instead of table and give it a manipulate, you will see I will have now the rational numbers, and I'm using a row function here to create a simple example of adding fractions and to format it into a better manner. So you see I can change the values of n or I can change the values of m, and I get the corresponding output result over here as well. So you can even use endpoints, or you can use step sizes that are symbolic expressions as well. So for example, I say, okay, for this I need it to go from maybe starting value should be symbolic value a, and I want it to go to maybe 10a, and I want to have a step size of a divided by 12. Similarly, m should be again a symbolic value a, and I want the range still to go to 10a, and I want the step size to be let's take it same 8 divided by 12. So I can have like a symbolic step size or a symbolic expression as well. So where I can change the values. I have given the ranges, so correspondingly I can develop different type of questions and see how it can go from here as well. So this is how you can also set the symbolic outputs, and you can use the step sizes. So symbolic outputs can be done, or you can have a specific step size. This step size can be, if you are interested in a step size of 10, so first the next value will be 10. So it will go in the step sizes of that. So depending upon your requirement, you can decide the step values for manipulate function as well. So let's move forward and look at some types of controls. So which types of controls are available in the manipulate function, and how you can utilize that. So manipulate supports a wide range of alternative ways of specifying variables, which generate different kinds of controls for that variable. So for example, if I have an example like this, so basically in this example what I'm doing is I'm doing a plot of sin x with a variable frequency n1 and another addition with the frequency n2, and I'm using now filling as a variable, and I say manipulate function that filling can be different types. So when I evaluate this, you see for these two frequencies I get the slider bar, but when I give a range of things, it automatically gives me like the row of buttons where I can select, I can change the variables, and then I can select the fillings like none, axis, top, or bottom. So you can give an extra level to this as well. But notice that if I add more, so what I do over here is Command L just copies the previous input, and if I give it some more values of the filling like automatic or any certain value I want, 0.1, 0.5 or 0 or maybe minus 0.5. What will happen when the list is a little bit more? You see in this scenario, Mathematica automatically analyze that the range is a little bit more and that having a row of buttons might not look that much aesthetically present. So what it gives you, it gives you a pop-up menu. So all these variables mentioned over here are now available in a pop-up menu where I can go forward and I can select it from the pop-up menu which I want to use. So similarly, if you want to have like checkboxes, so in that case you can have look, normally whenever there is a checkboxes, it's more like a true and false type of thing. So in the same example, if I do Control L and I take the same example and I say okay, frame, and let's frame be a variable, and then I mentioned that frame will also be a list where frame is either true or false. So you see, true or false. So when I have a true and false type of a functionality within the manipulate function, it automatically understands that it needs to give a checkbox. So if it is true, it will give me a frame on this. If it is, I uncheck it, it will remove the, because this is false, so that means there is no frame on that. All other features remains the same. So if you are using these specific values, true and false, you will always get a checkbox on that. So these choices are, of course, somewhat arbitrary, but they are designed to be convenient, and you can always override the automatic choice of the control type using a control type options. So if I use here and I say that control type should be a setter bar, or control type will be any other method, it will override that. So for example, if in the same example, if I specify that the control type should be a setter bar, so instead of having a pop-up menu, you see it has given me a setter bar. Whereas previously, automatically for this range of values, it would have given me a pop-up menu box over here. Okay, so you can have another type like a control type to be manipulator, or control type to be slider, and it will give you different types of options as well. And we will see a couple of how to add locators and 2D and 3D sliders over there as well. So sometimes it is even possible to use two different controls to adjust the value of the same variable. So you can have both a pop-up value as well as the slider bar connected to the value of the same value. So let's take an example over here. So in this example, what it is doing, you can do the same thing by having both the options. So I can have a slider bar also, where you can change and do the variable, or you can have a pop-up menu bar where you can select it. So you can do the same task either by a slider bar or a pop-up menu. This really depends on how you want to do that. So, and the list is not exhaustive. There are other possible control types like locator and 2D slider, which is coming up in the next sections of my talk today. So let's move forward and see how to set the initial values and labels in the manipulate function. So we will start. I will take one example, and then I will take the same example in the upcoming many sections, where I will show how it differs by adding different types of variables. So this is the famous example of making Lagrange's figures. So you will notice that when I run this manipulate function, you basically see nothing at first, unless you move the amplitude values like A1 and A2, and then you start using something, and then you change the frequencies N1 and N2. So unless you start using that, basically you see nothing. So you want to set some initial values, because currently by default the initial values were set to 0 and there was nothing to see. So it would be very convenient to set the initial value to something other than the default leftmost value, which is 0. So this is the leftmost value. So by default it will start from here. So instead of having this default values, you would like to add certain initial values into that. So for example, if you want to have an initial value here for A1, so basically what you will say, you said okay, A1 has an initial value which is 1, and you do this. So this is basically telling Wolfram Language that the initial value of A1 should be 1, and it should go from 0 to 1. And then when I execute it, you see the A1 is initially set to 1 over here. Similarly, if I want to add other values, like I want to say give the initial values to all of these parameters, like this. So basically what I have done is given the initial values to all of these parameters. So N1 has no initial value, A1 is given an initial value of 1, phase is not given an initial value, frequency 2 is given an initial value of 5/4, A2 is given no initial value of 1. So now you see I get some figure to start with. So I am not getting a default leftmost value when I run this command or when I execute this command. And it is fun to watch how you can shape these turns. So for example, you see if I move N2, how quickly is this changing. So if I press, like because I'm using Mac, so if I hold down the Option key, so if you're using Windows, it will be an Alt key. So if I hold down the Option key and now I drag it, you see how slowly the drag bar is moving. Without an Option key, it will move very quickly. But if I want this slide bar to move very slowly, like almost by down a factor of 20, I can click on the Option or an Alt button in Windows, and you see now the movement of the slider bar is very slow. It has reduced. So you can also play around and see how the slowly affecting of the slider bar will make certain effect. And you might have noticed that I am using a performance goal of quality over here. So this is just used to ensure that the parametric plot draws smooth curves even when a slider is being moved. So now the next step in the manipulate function will be okay, I can see N1, but it is not a very effective way to understand what is N1 or what is A1 or what is P1 for your end user, because you can enter any value over here. So it is basically a good idea to have some label so that your user or the person who is looking at this applet or this demonstration can understand it quickly. So for example, this N1 is a frequency. So I can say that N1, 1, and want to give it maybe a starting value of 1, and I say that this is frequency 1, maybe frequency 1, and then so you see now instead of N1 I see a label of a frequency 1. Similarly, if this is amplitude, I can say okay, amplitude 1. So instead of like N1 or A1, now I see that this is frequency 1, this is amplitude 1. Maybe if I want to this A2 as an amplitude 2, so I add over here amplitude 2. So similarly, you can add the labels for all of them, and after adding all the labels, your output will be like this, where you have all the labels mentioned. So your user is now more easy to understand that by using this variable I am altering the frequency 1, or I'm using changing the phase 1. So now this is more easy, understandable, and make more sense for the people to play around with this and see how this is working on that. So this explains how you set the initial values and you get the labels for that. So the next step will be to make this demonstration a little bit more beautiful. So how you beautify the control area is our next step. So again, there are a number of features that allow you to rearrange, annotate, and generally pretty up the control area to make sure it suits the needs of a particular example. So in the same example, you see this is on the, by default, this is on top of that. So, but I want these, all the labels to be on the left side of that. So what I take, if I take this input over here and I mention that the control placement, because up till now the control placement was default. So I say, okay, the control placement should be left. You see now all these labels are on the left side of that. So you can have a control placement left, right, top, bottom, depending upon how you want to make your interactive display visible to your user. And this, when you place this control placement, I put it under manipulate. So this is used at the level of the manipulate function as a whole. So it sets the default value of all the controls. But if you want to set the option where you can control each and every one where to put that, there are also certain ways you can control that. For example, in this one, you maybe say, okay, I want to have the controls for the frequency one separately, and I want to have the controls for the frequency two separately over here. So if I do that, maybe here, if I add another function, delimiter, you see now I have put a break, like a page break over here, where I can tell that, okay, this is for first parameter and this is for second parameter. If you want to have frequencies on one section and you want to see the amplitude on the second one and then the phase on the third one, you can also do that as well. So for example, so when you use the delimiter and then you rearrange the frequencies together, amplitude together, phases together, and then evaluate it, you see you can have the frequency 1 and the frequency 2 together, then a delimiter, then amplitude, and then the phase. Alternatively, you can also add certain strings over here. So maybe in this case over here, you say, okay, let's open this one, this output again. And you say, okay, this is for horizontal and this is for vertical, and how you want to let your user know that about that. So maybe you can just add over here that this is for horizontal change. So you said there is a heading come like horizontal, and then you say, okay, this below is for the vertical. So after delimiter, you can have a vertical heading over here, and then you can see you can beautify this more as a horizontal and vertical. And then you can add certain styles to that. So maybe you want this horizontal to be bold or with any other color. You can always wrap this in a like a style function, and you say, okay, I want this to be like bold, and I want this to be value to be 12, and you see now this is, or you say, okay, I want this value to be red, so this changes that. Similarly, you say, I want to have the same settings for this vertical, so just wrap this around a style function, and you can also tell this is bold 12, red maybe, and then you can beautify or add more features to make this more aesthetically representative. So more examples on how to complex arrangement or to create dynamic labels. We can study more, but that is not the scope of the today's session. We are today looking at the basic features of that. So this is how you can add and beautify. You want to have some more panels or addings on top of that. That you can also see my another presentation which I did on visualizations and graphs, how you can take it forward from there. So up till now we have only sees the sliders and those things. Now let's move forward and we'll talk about 2D sliders. How you can develop two-dimension sliders which allow you to use both directions of the mouse movement to control two values simultaneously. So whenever you are using a 2D slider, of course you have to give two different values, like a pair value of an x and y pair. So for example, you want to do a manipulate and you say okay, point, and this you have to do a pair, so it is -1 to 1 and the other is like from 1 to 1. So now you see you get a 2D slider where I can move this with my mouse and I get to change the values and I can see that. So you can get to see a feel of how the this works. So this is more like a 2D dimension for that. And no better example will be to see at this graphics. So if I look at this graphic, so there is a pointer bar and I can move my slider mouse over here. So it's more like a 2D slider where I have the range and I can have a graphic display corresponding to that. So this shows you more graphically how the value of a 2D slider correspond to a coordinate point. And to do something more interesting, we can apply this same 2D slider on our, instead of the 1D sliders on our earlier example. So if I apply this 2D slider on the same frequency figure, now I can manage both frequency 1 and frequency 2 together because they are paired together. So on one axis it will be frequency 1 and on the other axis it will be frequency 2. Similarly, the amplitudes of both and the phases of the both. So instead of having like a slider bar for each one, I can have a 2D slider. So instead of 6 one-dimension slider, I can control the same 6 parameters, but now I can do it 2 at a time. So this is interesting how you can develop that. So this is about how to develop the 2D sliders. Let's go forward and see more about okay, how to do certain more graphics. So I've done this example earlier and I'll just take this example for you to look at that. So you can see I can have a 1D and I can have a 2D slider on the same one. So the flexibility of the Wolfram language is that you can combine all the things together as well. I can have a slider 1 dimension and I can have a 2D dimension all in the one. So you can make it as interesting as you want or as detailed as you want. So similarly, another example over here. So you see control placements on left and right. and then I can have some, oh, yeah, so I should set some initial values so that you see something interesting. So without initial values, you need to play around and get to that. But if you set the initial values, which I told you how to do that, you can get the results also. So this is like a string example from creating a table from the sine and cosine different values and then displaying it all together. Because I said that Wolfram language is very sophisticated programming, so you can, it is possible to use manipulate to explore parameterized programs or algorithms all together. And this is very interesting to do that. So let's move forward and see how you can divide the locators. So up till now we have dealing with 1D or 2D sliders. Now let's take it more interesting, and we will create some interactive graphic examples which will have like a locator bar into that. So consider this same example which I did previously. So this is the same example now with a locator. So all I do is mention a locator, and as you can see I can just drag it and I can change it by using the locator. So the way I use, instead of using slider bar, I can use the locator value and I can change, and it corresponds to that different values. Even if you click on a certain value, any place in this panel, it will, the closer locator point will get to that. So in this scenario, because there is only one locator, so automatically this is coming over here. But if in an example, if you have more than one locators or you have multiple locators, the locator which is closer to that click will correspond to that. Let's take an example of that as well. So in this example, there are multiple locators. So there is one locator here, this is one locator. So instead of changing the values by using the slider bars, I can change the values by moving around these locators. So if I click here, this, because this locator is closer to this, it will respond to that. If I click here, this locator, because it was closer, it will correspond to that. So the nearest locator will jump to where you click and start tracking the mouse. So you can have just mentioned that this is a locator, which point it is, locator, and it will make the locators accordingly to that. Similarly, if you use the in Mac, if you use the command key, and in Windows it will be an I think the Alt key. So if I click on that and then I move it, you see, it will do that. So I can you click command and I can click on that and it will automatically take this value over there. So you can combine locator controls with normal manipulate variables, and you can use some sliders, and you can use colors, or you can control the appearance of the polygon. You can add all of these things together and then create something more interesting and colorful also as well. So you can have all of those things together. So for example, in this, I will be having locator, and I'll be having some slide bar, and then color chooser from here. I can have a 1D, and then I can have locators. And if I click command and I click somewhere, it will add another locator. So if I want to add another locator here, so I will click on the command in Mac and Alt in Windows, and if I do that, it will add another locator over here. So locator auto create has been true in this case. So I can add more locators. So if you are developing certain types of things, you can utilize that. So these addings is very useful when you are doing certain types of curve fittings, or who want to see how a certain value will go from one point to another. That will be very interesting in that scenario. So here I use the auto locator as true, so I can have a different order value. And if I want to change these values over here, I want to add another locator point, I can use command and click that, and it will keep on adding the locators. If I want to remove any locator, I will also hit the command button and click on this. So adding also, command click, it will add. If I hover on top of it and press command click, it will delete that locator from there. So if you practice a little bit of use, you can develop this from a scratch as well. So for example, this will be an interpolating function with the random real values, and you can have more locator by adding command or clicking on this and removing this. So you can add a lot more things. So you can have a locator or over here as well. Let's move forward and let's see some more example on 3D graphics, how you can do that. So manipulate is also on the 3D function also. So for example, if you want to have like a plot 3D, and you want to say, okay, I want to see sine, and is my variable, x and y are the space, and I will say that x is from 0 to 3 and y goes from also 0 to 3. If let's move n for the time being. This is my 3D, plot 3D. Even though if there is no manipulate, but still you can zoom in, zoom out, rotate and do that. But you can also have a manipulate over here, give a variable, this is the variable n, and then you tell Mathematica that this variable n goes from 1 to 5, and close the manipulate function. So now you have a variable n, and all those functions, features which I told you earlier, like adding a label, control placement, all those things will be available for all these functions. So either it's a symbolic or it's a graphic, you can wrap a manipulate function around that as well. So good thing is about that, all these functions like plot 3D and other built-in product functions, they automatically adjust their algorithms internally and settings when used inside the manipulate function. So in order to deliver increased speed when you move the cursor, you see when I move the cursor, you can see how quick the result is getting. So it is evaluating, changing the values of n, evaluating it, and then giving you the output result. So the rendering is almost looks like it's in a real time. Similarly, when you are doing in 2D, you can use the low-level graphics just as easy as high-level plotting commands also. Let's take another example I developed for you. So in this example, what this is doing is I have like two spheres. I can set the radius for these two ones, and then I have a locator bar where I can move it and I can see, and you can see the rendering is like real time. The moment I change the value of C, the corresponding result is almost like a real time. So this is how fast internally the rendering is happening, and it was giving you the result for that. Similarly, if you have a spherical plot and you want to see change the opacity of that and get to the result, you can have like a manipulate around that, and you can see I should set the initial condition, and see you can change the opacity also and see what's happening at the epicenter of this specific sphere. So you can change it from here and you can try to understand what's happening behind that. So you can always rotate these 3D graphics, even in a manipulate. Similarly, by clicking and dragging, similarly in an ordinary way you would have done before. So this is an example of using manipulate on 3D. Let's look forward at the types of output that are exported. And manipulate is designed to work with the full range of any type of outputs you can get within the Wolfram language. So, and it does not stop with graphical, algebraical output, or any kind of output that Wolfram language can give. You can use that inside manipulate. So I think it will be better to say all types of outputs are supported. So either you are using grid, column, panel, graph, plots, anything. This you can wrap that around manipulate around that and get the result for that. So for example, in this example, let's see. You see there is an example. So there is a grid, there is a table, and then you can wrap that around and you can get the result. And as I mentioned, the panel is also not restricted. As long as the panel will be required, the result will be corresponding commonly over that. And then you can wrap one type of manipulate inside another manipulate. So you want to have different manipulates together in different steps, like in a nested manipulate, you can also do that. So with that, let's come to a very interesting next step is saving definitions used inside manipulate. So for example, you are using a function like f of x, and let's give this function is like an x squared. So you define this function, and now you are using this function inside manipulate. So f of y, and you say that this y maybe goes from 0 to 1. So because currently your kernel is active, you just define f of x. So Wolfram languages understand what this function is. But what happens if you close this file? Because the kernel is stopped, this value is not done. So next time, either you change this cell into an initialization cell. So whenever you open this file, this value is initialized. But if that is not what you want to do, you can also do save definitions. So if you can add over here, save definitions, and this is true. Oh, there's a common issue. So now even if you close this file and then you reopen this file, it will save this function value along with the manipulate function inside it. So whenever this save definition is true, it causes to automatically build into the manipulate output a copy of all the definitions of functions which are referred into this manipulate. So this is basically saying that you put this as an initialization or you put save definition for that. You could have also used this same result instead of definitions. You could have also said that initialization, and then you could have done the initialization of and given the value that this initialization is and defined f of x here. So this has been equivalent to what have been the have a look at it why it's there, or maybe I misspelled something or I did something. Otherwise this has been equivalent to giving the values for that. Let me retry that. Okay, so here you go. So this is equivalent to doing like save definitions true or doing an initialization. This would have given the same results. So you can think of save definitions as a convenient automatic way of setting an initialization option. So I will always suggest you, whenever you are using a manipulate function, you might need to give the initial value as well as use save definitions is equal to true. Or you can use both if you like. So it really depends on how you can utilize that. Then manipulate function can also be controlled through gamepads and joysticks and using an USB controller devices, because online I cannot demonstrate that to you because there's no, I'm not doing physically in front of you, so I'll just I won't be showing that, but I just want to tell you that if you have a USB controller devices like Logitech and those joysticks and gamepads, the manipulate function can automatically detect the controller, and you can also make changes for that. I think there's a video on our Wolfram YouTube channel also where a person is controlling the drone through the joystick controller, and that is using manipulate on at the back end. So with that, let's move forward, and I'll do one last topic. I have a couple of minutes left, and I'll try to cover that in that time span, which is how you can do the auto run. So up till now, you need to move the slider to get the values over here. Let's see how you can use the auto run. So you don't have to move the slider and then you want it to run it automatically over here. So you can also do that by setting the drives over here. So you can also have an auto run animation slider, which basically which basically acts as a master control drive for all of it. So let's show you with the form of an example. And you see, you can have like this type of auto run, which I told you automatically from here. But normally I do not prefer auto run specifically in your notebooks, because it is a continuous calculation happening on the back end. So it is using your kernel to do that. It is using your CPU power to do that. But it is useful if you are deploying it somewhere where it will just keep on running in like in that format, or if you want to run that and save it as a video file and then utilize it in any other medium, then it is preferable in those scenarios. Otherwise, normally what I like is to have this as a manipulate as a static, and then I can use it from there and I can move it. But if you really want to do that, you can say auto run sequencing, and if I do it all, you can set those parameters in the command, and it will work on that parameters also. So there are certain things you can also apply into the auto run sequencing as well. Like you can give it some seconds, like run it for 10 seconds and then reverse after 3 seconds. So all those things can be done by doing the auto run sequencing over here. So, but let me mention you over here that one reason to care about the details in the auto run sequencing is that it is possible to use the export command to automatically generate an animation file. So you can also use an export command and develop an animation video from there also as well. So let's move forward to the last topic of how to do some bookmarking. Combinations of parameter values. So why you need this bookmarking is because in the manipulate function, particularly when there are many controls, they can be used to find it's very difficult to find which correct combination to show to your audience. So it is better to have a single output value in the form, so you can use as a static input, and then you can paste that snapshot command from the menu, and the result will be inserted in a new cell below the manipulate function. So let's take an example over here. So if I do this manipulate, and then you can add to bookmarks, so you can do an auto run also from here, from these features. The plus, you can also take a paste snapshot, and it will give the static dynamic module value at that specific value over here. So there are certain other features like initial settings. How to do that are also available by clicking on this plus sign, and you can set these values over here as well. But they are more interesting and more interesting to know and more valuable when you do the dynamic module and dynamic value, which most probably logically would be our next step, and our next session should be on the dynamic, how to develop a dynamic module, and how to use those values within the blocks and use the dynamic set. So that will be our next step, and most probably I'll make a session on the using the dynamic value for my next session. So that is most of the things I wanted to share today. We are almost hit the time also, and so what I'll do, this presentation is almost, you can see I have done the sections properly, so this can be shared also. So I will let's summarize what we did up till now, and then I will also be able to share this file with you guys. If you want, you can contact to your concerned person, or you can write me an email and I can share you the link of how to do that. So let's save this file, and this is also an example how within Wolfram language, how quickly I can do all the things on the go, and then in the end I have a very beautiful presentation also to share with you as well. So let's summarize what we did today. Is we knew that the manipulate is using a table function. So if you are comfortable using a table function, you will be very comfortable using manipulate. You can use symbolic outputs and how to define the step sizes in the manipulate. Types of controls, like automatically it will give you settler bar, but you can have if it is a true false, you can have a checkbox and all those things. How to set the initial values and the labels, because the labels are not understandable from here. How you can put the labels. We see how you can beautify the control area by placing control placement left, right, top, bottom, and adding some styles and other features of Wolfram language. We looked at how to do 2D sliders, how to use that in graphics, how to develop a locator where you can, instead of having a slide bar, you can move a locator and change the values. We looked at how you can manipulate the 3D graphics, how you will use save definitions, this is very important. I prefer you will be using this a lot of time. Every time you make manipulate, use save definitions. Auto run, you can always go and plus sign over here. You can have an auto run settings from here, or you can add some auto sequencing features also. Then in the land, we also checked how to you do bookmark and get the specific snapshot of that. And with that, I will close the session today. And there is no prior questions in the chat. So Thank you everyone for your kind comments. You liked the session today. I'm happy with that. Do remember to like this talk, and if you like, you can subscribe to my channel so that you automatically get a notification of my upcoming presentations and my upcoming sessions. So if there are no questions, I'll take the leave, and I'll say thank you everyone for joining me today. Even if you still have any questions, you can drop in a comment box and you can reach to me. Thank you so much and have a good day. Thank you. Bye-bye.